Hi, welcome back in the lecture series of IC Fabrication. This is session 3. In the last session, session 2, we have talked about that how basically we form this ingot from the basic raw material like sand, wooden chips, etc. In today's session, in this session, we will talk about how basically wafer is fabricated from ingot. Okay, so we will talk about that how basically we will achieve this from this. In a first look, if we see, you can say that wafer preparation is very easy. We have to simply cut this. Whenever we will cut it, we will get simply a circular disc like this, right? So it seems to be a simple, straightforward one-line process that we can achieve from this to this shape simply by cutting it with a saw, right? But this is not. This is true, but this is not actually so simple that just a one step is there. There are a number of steps inside this. Okay, so let's have a look about this process in a little bit of detail. So to understand this, the basic process steps for wafer preparation are written here. From the crystal growth, which we have done in the form of ingot, we shape it, then we slice the wafers, then wafer lapping and edge grinding is done, then etching, polishing, cleaning, inspection, and then finally we pack the wafer and we prepare it for further fabrication process. Okay, now let's have a brief discussion about these steps one by one. Let us have the first step, that is crystal growth to shaping. We have grown this crystal, that is silicon ingot. Now first of all, we have seen that the edges are not perfectly circular, so we may cut the edges first from both the sides. Okay, so in this manner we will get this shape, right, which we may say that this is almost circular, continuous circular shape, almost, but not perfect. It may not be perfect. Its dimension may be, let us say its radius are here, but its radius may be r less than or greater than r here, right? So first of all, we need to form a complete regular structure so that whenever we cut, we should have all the discs of same dimensions, so that whenever we will fabricate, because of the little difference in the dimension, a number of course may waste. Okay, so first of all, we have to make the complete cylinder in a totally same shape. Okay, so first step, as we have said, that crystal growth to shaping will be done with this first sub step, that means we cut the sides, and then to make the whole radius same, what we should do, if let us say this is the shape and here is the radius more and here is the radius less, then we have to grind it wherever the radius is more, so that uniform with same radius we can achieve the end. Okay, so the next step is shown here, that we basically have a diamond cup wheel which rotates continuously over the ingot, and we move the ingot also. Okay, so that we get the perfect similar shape from all the sides. Okay, so that it will rotate, the ingot will rotate continuously, and this cup wheel will come onto all the surfaces and it will give it a proper shape. Okay, so we can say that now, after processing this step, we have achieved this diamond grade, diameter grade. Grinding is done, and hence we have achieved the perfect shape. Now, even now, we will not cut it. What more is required? Flat grind. As you can see that here is a flat is made. First we said that we need a circular disc, but now we are flattening it at the corner. There may be one flat or there may be more than one flat. What is the purpose behind the flat? If you will cut it and you will get the circular disc, from which point it is starting and where it is ending, can you find that? No, you can't say this is the starting point, this is the ending point. If we have if we have, let me draw it here. If we have this circular disc with one flat here, okay, then seeing this flat we can easily say that if this is the starting point, then this will be the ending point here. It will move in this manner. We can easily find that. Okay, so flats are required for the purpose to find out where is the die, which is the die, what is the orientation of the die inside this wafer. So there may be a requirement of only one flat or maybe more than one flat. So at least one flat is definitely required, which is known as primary flat. Okay, how will we make a flat? We have to again grind the complete wafer. Okay, so let us see. This is a flat grind that now we will not grind in this manner, but we will take a flat circular shape as shown in this ingot shaping here. You can look here. Then when this will rotate and move over this surface, it will grind it will create a flat. Okay, now the next step is cutting and hence making the slice of wafers. Okay, so from shaping has been done, now wafer slicing is required. For this pictorial diagram is showing that how basically it is going on, that we have a large diameter cutter and we put wafer inside that and we cut it in this manner. This picture may be more clear with the help of maybe with this diagram, that we have large diameter cutter here and we put the wafer inside of this. So when we move it inside, this cutter cut, cut, and it moves continuously. So in this manner we get circular disc continuously. I think this diagram will be more clear with the help of this view, that how basically we are cutting. This is rotating and ingot is coming continuously inside. So every time it comes, the cutter cuts it and makes different flat circular disc. Okay, so it seems to be simple operation of cutting and hence making the circular disc. But when it cuts it in this manner, because of a little movement of the wafer, when it cuts, it may cut it with an angle, and hence the circular disc we have achieved. Okay, maybe have more thickness at this point and less thickness at this point, right? So for this we have to again do some more operations. Okay, first of all, the edges, whenever we have cut it, the edges, these edges may not be perfect now. So first of all, we will take, we will rotate at one speed here in one direction and we will rotate this cutter with another at in opposite direction simply. Okay, if it is rotating in, if the wafer is rotating in clockwise direction, then opposite in the counterclockwise direction, this grinder will rotate and hence it will smoothen the outer surface. Okay, here you can see the flat is also there. Okay, so this is the first step known as wafer edge grinding. Now what about the thickness? As I said that thickness may be more at one point, thickness may be less at another point, etc. So we have to press this wafer. We have to press this wafer so that if little bit amount of thickness change is there, it gets same. We will be able to achieve the same thickness. Okay. So this is the first step. We have seen that edge contouring process. This we have already discussed. Next one is wafer lapping. We keep a number of wafers inside this machine, okay, here, and then we press it. Wafer lapping is a global polarization process that improves wafer flatness by removing surface damage, often from backside grinding. Okay, as we have discussed, lapping takes place between the two counter rotating cast iron plates and either an abrasive film or slurry. So when we are putting different wafers inside this, what we are saying that from the bottom side we rotate it in one direction. We rotate it in one direction, and from the top side when we lap it, when we press it, we rotate it in another direction. In this manner, pressing and rotating in opposite direction. Then only we will get the complete perfect shape with width, thickness same in all at all places. Okay, of the circular disc known as wafer. And wafer should not damage. We should use some liquid material also to avoid too much friction. That is known as slurry. Okay, this diagram is showing us that if a number of wafers are placed in this and dipped into the solution, which is for the purpose of etching. So operation is taking place at once for number of wafers. We must we put it inside the solution for a definite amount of time. If we will put it for more amount of time than the defined limit, then it will etch everything. Okay, and if we will put it for less amount of time, it will not be able to etch the required material from the wafer surface properly. So we have to put it inside the solution for a fixed amount of time to etch the required material whatever we want to etch from the surface of the wafer. You can see from this diagram here that inside this cabinet a number of wafers are going at once. So operation is taking place on to all the wafers at once. Okay, you can see it from here also. So schematic of polishing. So after this lapping, what is the and etching etc. What is the next step? We should polish our wafer. Okay, to remove the roughness and give the smoothness. Okay, so slurry is dipped, slurry is here, and polishing pad polishes the complete wafer. So this is just the diagram of actual machine, how basically polishing taking place. This is the slurry material. Okay, and the operation is taking place here inside this. Now let us move further. The next sub step is scrubbing. You can see that a brush like thing is moving and hence removing any other dust particle or anything remaining onto the from the surface or even the excess polishing material. It's just scrubbing and hence removing the same. Okay. Finally, the final inspection is done onto the wafer for its diameter, metal contamination, and various other parameters. And hence, the wafer is ready. Now, this wafer is ready for different fabrication steps to be taken place onto this wafer to make the chip. Okay, so we can summarize the point that silicon shaping steps. In summary, we can say that the first step was remove the seed and tang end from the ingot. Then surface grinding is done. Then flats, maybe primary, maybe only or maybe secondary also. Then slicing is done. Then lapping, edge contouring, etching, polishing, chemical cleaning, guttering, I have not discussed, and final inspection. Okay, so these are the sub steps of silicon shaping process, which in the starting we said that simply we can cut it and we can achieve. Okay, no, there are a number of steps as we have seen here. Here are the two YouTube videos which will give you more detail about the process in detail. Okay, you can see the whole fabrication process from these videos in detail. These are the good videos, and a number of other videos are also available on YouTube. You can refer them also as per your interest. So finally, we have achieved these circular discs known as wafers, which have no circuit on over it right now. They are only purified, highly purified silicon wafers. Okay. Now, as we have seen that there are cores and dies which we have to fabricate now from this. So this is the next step. We will clear it with the help of the fabrication step for NMOS as well as CMOS in the next two sections. Okay. So till then, thank you.